So we're going to start to look at our angles that are larger than 90 degrees, which we call non-acute angles. And it turns out that sketching them isn't that bad, but we have a certain convention that we use. But the thing to keep in mind is that we're going to be elevating this to evaluating trig functions of angles that are larger than 90 degrees, which is kind of weird to think about because we're so used to talking about right triangles that it's going to be very strange to go to this new area. So just to get kind of an overview, and I'm just going to go through these notes really quickly here. Hopefully you have your copy of your notes handy there. So when we're sketching an angle, we use an XY plane, as you can see in these examples below. So we're going to draw we're going to draw our XY axes. And what we have is we start the angle on the positive x-axis, as you see here with my 110 degree angle here. And we move counterclockwise, and there's a reason for that. We move counterclockwise until we reach 110 degrees. So just realizing that when I go from the positive x to the positive y-axis, that's 90 degrees. So I'm going to a line segment, as you can see drawn here. We're going 20 degrees more to make an angle 110. And as you can see, we have the same thing for 240 and 360. And then we have negative angles, which since positive angles are measured counterclockwise, negative angles will be measured clockwise. So starting with the positive x-axis, if I want negative 45 degrees, I go 45 degrees in the clockwise direction, as you can see in that first angle, followed by negative 240 and negative 360. And notice that 360 is a full revolution, which that should be no surprise to us by now. We know that there's 360 degrees in a circle. And notice, though, that the 360 degrees and the negative 360 degrees start and end at the same place. We call these kinds of angles coterminal, and it's not specific to 360, but angles are called coterminal if they have the same they always start at the positive x-axis, if they have the same terminal point. And we're going to talk about how to figure out what coterminal angles are in a moment. Okay, so just to kind of reiterate, we can also talk about angles that are larger than 360. They just represent angles that are more than one revolution. So here's 450 and 600 for your viewing pleasure. You could also talk about a negative angle that's more than 360. Negative 450 would just be starting at the positive x-axis and going in the clockwise direction 450. So getting to coterminal angles, we say that two angles are coterminal, again, if they share the same terminal side or terminal point, whichever way you want to look at it. So above here, let's look at 240 and look at 600. Now 240 is this one here, and 600 is this one here. Notice those end at the same terminal side, okay? So what does that mean is our pattern or our rule for finding coterminal angles? Well, as you can probably tell, if I have an angle, I can either add a revolution or subtract a revolution to get another coterminal angle. So that's going to be our rule of thumb. We add or subtract some multiple of 360. Okay, so let's look at our example here, and then we'll say that we've accomplished coterminal angles. So if I have 40 degrees, I want two angles that are positive and two angles that are negative that are coterminal to 40. Well, the first positive angle, I'm going to add 360, and that's going to be 400 degrees. Technically, these should all be degrees. And I'm going to add another 360 to get another coterminal angle. To get negatives, I'm going to subtract 360. So that's negative 320. And if I subtract another 360, that gives me negative 680 degrees. So there is the answer to our question. All four of these angles, and I encourage you to try to sketch them, are coterminal to 40 degrees.